So in this video, I'm going to go over the Unit 2 test review. So first, number 1 talks about stating the rules for the following transformations, and you're going to need to know these for the test in a variety of ways, but let's go ahead and talk about that. Reflection over the x, I always tell my kids it's a change in the y. So this is x, comma, negative y, which means changing the sign of y. Reflection over the y-axis is a change in the x sign. Reflection over the line y is equal to x, they just switch positions. And then we have a translation along the vector AB, so that's going to be x plus a, comma, y plus b, recalling that that vector tells us how the x changes with the a and the y changes with the b. A rotation 90 degrees about the origin. I'm going to talk to you about the logic behind this again. So here again, we're talking about negative, positive, in this position over here. Everything negative and positive in the first and second. We got negative and negative here. I don't know why I keep doing that. Let me go back here and try this again. Okay. So we got negative, positive, negative, negative, and we have positive, negative here. This is 90 degrees, this is 180, and this is 270 because each of these quadrants represents 90-degree rotation. If we start with x, y, and if we started with an object that was this way, and this was the number, let's just say 2, 1, and we flipped it, then it would have come up like this. So now it would have been at 1, 2. So these flip in these positions, and obviously we know because the first thing is negative, we're going to keep it negative. And down here, same thing. If we flipped it down, the same thing would be true. The numbers would have flipped positions. So that's why it's going to be yx here. And again, the second thing here is always going to be negative. And everything down here in 180 degrees is negative. So this is going to be negative x, negative y. This is how I logic out what the rules are. So a rotation 90 degrees is negative y, comma, x. 180, negative x, comma, negative y. And 270 is y, comma, negative x. So I do that grid on my paper first because it helps me to remember what the rules are. Just want you to know that I changed the K, L, M, N prime numbers here because I discovered an error as I was working the problem. So you might want to do that first, and then you can talk through what the transformation is. So I'm going to go ahead and plot these points: negative 1, negative 2, negative 1, negative 2 right here. Sorry, negative 1, negative 2 is right there. And my L will be negative 4, negative 2. 1, 2, 3, 4. 1, 2. Right there. So this is my L prime. This was my K prime. Then we've got M, which is negative 4, negative 5. Negative 4, negative 5, which was M prime here. And then N prime is here at negative 1, negative 5. So this is our new square because it's 3 by 3. And I'm going to go ahead and label these points up here too because I think it'll help you all to see. This was our K, this was our L, this was our M, and this was our N. Now I want you guys to notice that it looks to me like a reflection. It looks to me like a reflection because the K stayed across from the center, from the origin. N stayed to the right, bottom right. L stayed top left, and M stayed outside. So what I want you guys to see is if I start drawing me some lines here, just from those three, those are parallel. And if I was to draw a line of reflection straight down through the middle of here, then I see that that segment and that segment are congruent, and this segment and that segment are congruent, and that segment and that segment are congruent. So if I can draw perpendicular bisectors, and this is a right angle to all of these as well, then I know that this has got to be a reflection. And indeed it is. It's a reflection. And it just so happens that it's a reflection over the line y is equal to negative x, because that's that line. But you just need to know that it's a reflection because it just says to identify the transformation. Now down for number 3, it says a triangle has the vertices A, -2, 3, B, 2, 1, and C, 1, 0. After the transformation, the image of the triangle has the vertices of A prime, B prime, C prime. Identify the transformation. So if we plot these points, ABC and ABC prime, again, you should be able to quickly see that this is a translation. So let's look again. We have A to A prime, C to C prime, B to B prime. Now, all these are parallel and the same length. That's what tells us this is a translation. So notice that all these lines that we just drew are parallel and they are the same length. So then we just want to count from A to A prime. And so if we go from A, which is -2, 3, down to A prime, which is -2, -3, we can see that this didn't change at all. But to get from 3 to -3, we had to subtract 6. So that means that our translation is 0, -6, if we talk about a vector. And it moved down 6 units. It didn't move left or right at all. Now we're going to use the rules for number 4 that we talked about earlier. Reflection over the x-axis. That means we're going to change the y. So that's going to give us the point -5, -8. So I'm going to write the rule first. If you guys remember, I said write the rule, apply the rule, and then plot the points. Then we're going to reflect over the x-axis or the y-axis. That's -x, y. Be great if I could write. That one's going to be 5, 8, because again, we're changing the sign of the x. Reflecting over the line y is equal to x. This is going to be y, x. So we're going to then just say 8, -5. They just switched positions. That's all they did. Translated 5 units to the left and 2 units down. So if we were to write that as a vector, 5 units to the left, that's -5. 2 units down is -2. And if we were to write that as a rule, sorry, that should have been a vector, that's going to be x -5, y -2. And when I do that, I get the point -10, 6. Translated by the vector, actually, I don't think y'all had that one. Rotated about the origin 90 degrees. Okay, so again, we're going to write the rule. So 90-degree rotation is -y, x. We're going to apply that rule. That's going to give us -8, -5. And then 180-degree rotation is -x, -y. That's going to give us 5, -8. And just for the sake of it, let's just say a 270-degree. And that would have been y, -x. And when we do that, it's going to be 8, 5. Okay, so for number 5 through 7, I kind of want to bring something to your attention. If you use the points to do it, you're going to get different answers than if you use the points on the graph. So I kind of put that up here. The points that were written up here were not the same points as on the graph. And I want to bring that to your attention here. Because if you notice this point right here, point B, do you notice point B? Point B was 3, 0. It was between the 2 and the 4. And down here, point C was 2, -5, because again, it's between the 4 and the 6. Same way over here. So depending on which sets of points you use, you might get a different answer. So let's kind of talk through both of these. So for number 5, we're only using point B, so we're going to do both B's. So we've got B, our first B was 4, 0. And so we're going to do that one first. It says that we're going to rotate at 180 degrees. That means we would do -x, -y. So our B prime would be -4, 0. Then we're going to take that B prime and we're going to move it by the vector. So this is going to be -4, 0. And so then we're going to go x plus 6, y minus 9. That's our rule. So we're going to add 6 to -4. That's going to give us 2. So our B double prime is going to be 2. and 4 minus 9 is negative 9. So that would be this set of points up here if we use those. And then we're going to talk about the other set of points now, this point right here, the ones from the graph. So again, our B would have been 3, 0 for this. So once again, we're going to use that rule up there, negative x, negative y. So our B prime would have been negative 3, 0. Then we're going to add 6 and subtract 9. So we're going to add 6 to negative 3. So that's going to give us 3. And we're going to subtract 9 from 0. So that's going to give us negative 9. So that would have been our new B. And again, it depends on which set of points you use. If you use the points from the graph, it was the blue. And if you use the points that were written, that's the red. So number 6, we're doing point C. So we're going to start off with doing the blue. So C was 2, negative 6. It says we're going to reflect it across the y-axis. That means we're going to change x, negative xy. So that's going to be negative 2, comma, negative 6. Then we're going to move it along the vector, negative 2. So that's x minus 2, comma, y plus 5. So that's going to give us C. This was C prime. C double prime would be negative 4, negative 2 minus 2. And then negative 6 plus 5 would be minus 1. So that would be if we used the point up there, 2, negative 6. And then if we use the point from the graph, C would have been 2, negative 5. Same rule we're going to use. So that's going to give us negative 2, negative 5. And then when we subtract 2 from that, our C double prime is still going to be negative 4. But now it's going to be negative 5 plus 5. So that's going to give us a 0. All right, let's do this with this final point, D. So quadrilateral ABC is reflected over the y-axis. So once again, we're going to do point D now. And our original point D was negative 6, comma, negative 6. We're going to reflect it over the x-axis. That's going to be the y-axis. That's going to be negative x, comma, y. So it's going to make it 6, comma, negative 6. Then it says we're going to reflect it across the x-axis. So that's going to be x, comma, negative y. So that's going to give us D double prime of 6, comma, 6. Now when we use the point from the actual graph, we got D, which is negative 5, negative 5. Again, our rule. So that's going to make it D prime is going to be 5, negative 5. And D double prime is going to be 5, comma, 5. Number 8 says write a rule using the arrow notation if you would like to translate a figure. So 8 units right. So we're doing, we're only changing the x value because we didn't do up or down. That's our rule. 5 units left and 2 units down. Those are both moving in a negative direction. So this is going to be x, y becomes x minus 5, y minus 2. 8 units right and 5 units up. So our x, y is going to go x plus 8, y plus 5. And then 9 units down, our x, y is going to change. The x isn't going to change at all, so it's just going to be x. And we could say 0, we could say plus 0, but it's only moving down, so it's going to be y minus 9. So those are our rules applied to those changes, up, down. So number 9 says the triangle RST is rotated 90 degrees about the origin and then reflected across the y-axis. Identify the single transformation that moves the triangle from its starting location to its final location. So all we have to do here really is look at one of our points and compare it to our final point. So let's look at S. So S is 1, 1, 2, 3, 4. So this is 1, 4. And then let's look at S double prime. That is 1, 2, 3, 4. and 1 up. So if we look at this and we want to be able to compare it, what do we notice? What I notice is that the numbers just flip positions. That's all they did. So this would be the rule y. Let's write it as a real rule. So we'll say x comma y became what? Y comma x. And what is that? That's a reflection over the line y equals x. That's what that is. Number 10 says to rotate the figure with the points j, k, and l and m 90 degrees about the origin and state the image point. So that rule, 90 degrees, is going to be negative y comma x. So that's what we're going to do to all these points. So our j prime, we're going to go 2, 1, and then we're going to make that negative. Our k prime, we're going to go 4, 1, and we're going to make that negative. Our L prime, we're going to go 5, 3, and we're going to make that negative. And our M prime, we're going to go 3, 4, and we're going to make that negative. Then we can plot those points. So when we plot JKLM, when we plot JKLM prime, you should be able to see that it rotated. JM was on the bottom and it goes almost vertical. With number 11, it says rotate the figure points G, H, J, I, J 180 degrees about the origin and state the image points. Okay, so here again, we're going to write our rule first, and our rule is going to be negative x, negative y, and that really just means we're changing the signs of everything. So our G prime is going to be 3, 4. Our H prime is going to be 2, 1. Our I prime is going to be 1, 1. And our J prime is going to be 0, 3. Then we would plot those points. So when I plot those points, you can now see that GHIJ went from quadrant 3 to quadrant 1, and that's what we would expect it to do if it was rotated 180 degrees. And remember, you should always be making predictions about where you think these things are going to go based on the rules that are being used. Number 12 says translate the figure with the points E, F, G, H along the vector 5, negative 5, and state the final image points. Now we know this means x plus 5 and y minus 5. So here again, we're going to add 5 to all of our x values, and we're going to subtract 5 from all of our y values. So when we do that, we get E prime, F prime, G prime, and H prime. And when we plot these again, we should be able to see that this image moved 5 to the right and 5 down. And that's exactly what happened to each of our points. Number 13 says to translate the figure with the points I, J, K, 7 units right and 5 units up. State the vector along which the figure was translated. So our vector is just going to be 7 right, that's 7, and 5 up. These are both going to be positive. So when we're doing this, again, we're going to do x plus 7, comma, y plus 5. So we're going to add 7 to every x value, and we're going to add 5 to every y value. So when we do that, again, we should see that this image moves 7 to the right and 5 up. Every point in this image moves 7 to the right and 5 up. Number 14 says reflect the figure with the points V, W, X across the y-axis and state the final image point. So again, we're going to write our rule. So if we're reflecting across the y-axis, it's our x that's going to change. So we're changing the sign of our x. So we're going to write that rule first, and then we're going to apply it to all these points. So V is going to be negative 1, 4, or sorry, V prime. W prime is going to be negative 2, 5. And X prime is going to be negative 5, 1. Those are going to be our 3 new image points. So when we plot the triangle BWX, we should be able to see it reflect across, which means if it was in quadrant 2, it's going to quadrant 1. If it was in quadrant 1, which it was, it's going to quadrant 2. Number 15 says we're reflecting the points H, G, F across the x-axis. So again, our rule is going to be x comma negative y, because it's a reflection across the x. We change the y. And then we're going to look at our points. So again, our original image was mostly in quadrant 1, and if it's being reflected across the x-axis, it's going to go mostly to quadrant 4. And that's exactly what happened here again. Number 16 says reflect the figure with the points v, w, x, y over the line y is equal to x, and then reflect over the y-axis and state and graph both image and points. Okay, so the first thing we're going to do here is over the line y equals x, so that's going to be y comma x. That's going to be our first, that's going to be our prime transformation. And then it says reflect over the y-axis, and that would be a change in x. So those are the two rules that we're going to apply to all three of these points, and then we're going to plot them. So notice what I did here. I put the rule over all my red, where I transformed all of those points by reflecting them over the line y is equal to x, and then I took those points and I transformed them by reflecting them over the y-axis. And you can see here, again, we started out in quadrant 3, and when we reflected over the line y is equal to x, they moved to quadrant 4. No, sorry, we started out in quadrant 2 and we went to quadrant 4. And then when we reflected over the y-axis, we went back to quadrant 3. With number 17, I'm going to walk you through the process. So the three words I told you my students to use was subtract, apply, and that means apply the rule, and then add. So that's the process we're going to use as I walk through this problem. So it says point A is at negative 2, 1. Negative 2, 1 is right here. That's our point A. And then it's going to rotate 270 degrees around the point 1, negative 1. So 1, negative 1 is right here, and that's the point we're going to rotate around. That's our point P. So what we want to do first is we want to write our point A. That's going to be negative 2, 1. And remember, we're going to subtract first. So we're going to subtract from that the point 1, negative 1. So we're going to subtract the point 1, negative 1. So I want you guys to really watch this process. When we subtract 1 from negative 2, we get negative 3. When we subtract the negative 1, we are actually adding it. So that's going to be 1 plus 1. So this is going to end up being 2 here. Okay. Then we're going to talk about applying the rule. So the rule is a 270-degree rotation. So this was our subtract. Next, we're going to apply our rule. So we're going to apply the rule to the point we have right here. We're going to apply the rule for a 270-degree counterclockwise. So that's going to be y comma negative x. So that's what we're going to do next. So we're going to swap positions here. So this is going to be 2, and this is going to be negative 3. And we're going to change the sign of the x to a positive because it was a negative 3. Because it shows us that we changed that sign. So that's our new point. Then we're going to add back the point that we subtracted. So that's going to be our next step. We're going to add back to this point. You know what, let me take that off of there. We're going to add to this point what we subtracted before. So, whoops, put it in the wrong place, y'all. So let me do this again. It's not bad for y'all if I do this again. So again, we're going to apply the rule. So we're going to make this our y there, and then we're going to change this to a positive 3. Okay, and then so we're going to add to that the point that we subtracted earlier. So now we're going to add the 1 and the negative 1. Remember, when we add a negative, we're actually subtracting. So our final point here, so this was now adding. So we're going to do 2 plus 1, that's 3, and we're going to do 3 minus 1, and that's 2. So that's our final point right there, 3, 2. And this is our A prime. And so if we were going to plot that, we would plot it at 1, 2, 3, 1, 2 up here. And that's our A prime right there. So remember the process: subtract, apply the rule, and then add. This last question down here says, does the following figure have rotational symmetry? Well, for it to have rotational symmetry, we would have to be able to draw more than one line of symmetry. Now, I could cut through here, and even if I cut through there, the shape does not look exactly the same to me on either side of there. Well, maybe. But even then, if we divide 360 by 1, we get 360, and that does not represent rotational symmetry. If we have an image that had dots in all of these places, like a dot here, and a dot here, and a dot here, and a dot here, then we would be able to draw more lines of symmetry. We could cut that all the way through each one of those. Let's see if I can do this. So now we have 5 lines of symmetry, and we would do 360 divided by 5. And I'm thinking that might be like 72-ish. I don't remember, but just giving you that, guys, as an example. So when we talk about rotational symmetry, the question is, how many degrees can I rotate this thing to get it right back on itself? And in this case, because of that dot, I can only do it once. If you recall, there were some images where we could, if we can draw lines of symmetry, those lines of symmetry, we can then use those to divide them into 360 to figure out exactly what the rotational symmetry is.